When upgrading an existing underground service, several procedures can minimize downtime. Firstly, conduct a thorough site survey to determine the location and condition of the existing service. This includes identifying the path of the underground conduit, the location of the transformer or meter box, and any potential obstacles or hazards. Obtaining necessary permits and approvals from the local utility company is also important. This step ensures that the upgrade complies with all applicable codes and regulations and avoids any potential delays or fines. Schedule the upgrade with ample lead time to allow for coordination and materials procurement. This involves coordinating with the utility company, the customer, and any other involved parties. Procuring all necessary materials such as conduit, wiring, connectors, and grounding hardware ahead of time prevents delays. Secondly, excavation and disconnect procedures need to be followed carefully. Carefully excavate around the service entrance to minimize damage to existing lines. This requires using appropriate excavation techniques such as hand digging or vacuum excavation to avoid damaging any underground utilities. Safely disconnect the existing service at the utility transformer or meter box. This involves energizing the service and verifying that it is no longer energized. Isolate the service line from the rest of the electrical system. This prevents any accidental re-energization of the service during the upgrade process. Thirdly, remove the existing service conduit and wiring. Install new conduit and wiring that meets the upgraded requirements. This involves selecting the appropriate size and type of conduit and wiring, and ensuring that it is installed in accordance with all applicable codes and regulations. Ensure proper grounding and bonding. This is critical for safety and to prevent electrical shock hazards. Fourthly, conduct a thorough visual inspection of the new installation. Perform electrical testing to verify proper continuity and insulation resistance. This includes testing the continuity of the grounding system and the insulation resistance of the wiring. Fifthly, connect the new service to the utility transformer or meter box. Restore power to the customer's premises. This involves coordinating with the utility company to energize the new service. Sixthly, carefully backfill the excavation area to prevent soil settlement or damage to the new service. Remove all construction materials and debris. Additional measures to reduce downtime include utilizing a temporary generator. Consider connecting the customer to a temporary generator during the upgrade to maintain essential power. This is especially important for customers who rely on electricity for critical services, such as medical equipment or home-based businesses. Communicate with customers, keeping them informed of the scheduled outage and estimated downtime. This helps to manage their expectations and minimize any inconvenience. Coordinate with the utility company, establishing a clear timeline for the upgrade and working closely with the utility company to ensure a smooth transition. Plan for contingencies, having a backup plan in place in case of unexpected delays or issues during the upgrade. This might involve having extra materials on hand or having a backup crew available to assist with the upgrade. Consider off-peak hours, scheduling the upgrade during off-peak hours when demand for electricity is lower to minimize disruption for customers. When pre-planning, ensure to identify the existing service's voltage and amperage. This is typically found on the meter or the service panel. The upgraded service must meet the customer's current and future electrical needs. Calculate the load requirements based on appliances, lighting, and other electrical equipment. When excavating, always call before digging to locate any underground utilities. This prevents damage to gas lines, water lines, and other utilities. Use caution when excavating near existing utilities. Hand digging or vacuum excavation may be necessary to avoid damage. When disconnecting the existing service, use proper lockout/tagout procedures to ensure safety. Verify that the power is off before disconnecting any wires. When removing the existing conduit and wiring, inspect it for damage or deterioration. This may indicate potential problems with the electrical system. When installing new conduit and wiring, use the correct size and type for the application. Refer to the National Electrical Code, NEC, for guidance. Ensure that all connections are tight and secure. Loose connections can cause overheating and electrical problems. When grounding and bonding follow NEC requirements, proper grounding and bonding protects against electrical shock and equipment damage. When inspecting the new installation, check for any exposed wires or damaged components. Repair any defects before energizing the service. When performing electrical testing, use calibrated test equipment. Verify that the equipment is functioning properly before using it. When connecting the new service, work closely with the utility company. They may have specific requirements for connecting to their system. When restoring power, inform the customer that the power is being restored. Ask them to turn off any sensitive electronic equipment before the power is turned on. When backfilling, compact the sole to prevent settling. Use appropriate backfill material for the application. When planning for contingencies, have a plan in place for dealing with unexpected problems such as damaged conduit, corroded wiring, or unexpected utility conflicts. When considering off-peak IOs, check with the utility company to determine when their off-peak IOs are. Schedule the upgrade accordingly. Consider using a ground rod to supplement the grounding system. This is especially important in areas with poor soil conductivity. Ensure that the ground rod is properly installed and connected to the grounding system. Use a torque wrench to tighten connections to the proper torque. This prevents loose connections and overheating. Consider using a surge protector to protect sensitive electronic equipment. This can help to prevent damage from power surges. When working with underground electrical systems, be aware of the potential for underground water. Take precautions to prevent water from entering the conduit. Use waterproof connectors and sealant to protect connections from moisture. Consider using a tracer wire to locate the underground conduit in the future. This can be helpful for future maintenance or repairs. When working with high-voltage electrical systems, use appropriate personal protective equipment (PPE), such as rubber gloves, safety glasses, and insulated tools. Always follow safe work practices when working with electricity. If you are not qualified to perform electrical work, hire a licensed electrician. A licensed electrician has the knowledge and experience to perform the work safely and correctly. Understanding the NEC is essential for safe electrical installations. The NEC provides detailed requirements for all aspects of electrical work. Staying up to date on the latest NEC changes is important for ensuring that electrical installations are safe and compliant. Electrical safety is paramount. Always put safety first when working with electricity. Follow all safety precautions and use common sense. Electrical hazards can be deadly. Be careful and take your time. Reviewing local codes and regulations is also crucial. Local codes and regulations may have additional requirements beyond the NEC. Check with your local building department to determine what codes and regulations apply to your project. Choosing the right materials is important for the longevity and reliability of the electrical system. Use high-quality materials that are designed for the application. Inspect all materials before using them to ensure that they are in good condition. Proper documentation is essential for future maintenance and repairs. Keep detailed records of all work performed, including materials used and test results. This information can be helpful for troubleshooting problems in the future. Training and certification demonstrate competence in electrical work. Consider obtaining certifications from organizations such as the National Electrical Contractors Association, (NECA), or the International Brotherhood of Electrical Workers (IBU). These certifications can help to demonstrate your skills and knowledge to potential employers and customers. Continuous learning is essential for staying up to date on the latest technologies and best practices. Attend training courses, read industry publications, and network with other professionals to expand your knowledge and skills. Remember to properly size the conductors according to NEC Table 310.16 based on the ampacity of the conductor and the overcurrent protection device. Also refer to NEC Section 250.122 to properly size the equipment grounding conductors. You must choose the correct conduit based on the environment and the number of conductors, as well as adhering to fill requirements in Chapter 9 Table 1. In terms of voltage drop, NEC section 210.19. A1 informational note number 1 and NEC section 215.2. A3 informational note number 2 recommends voltage drop should not exceed 3% for feeders and 5% for branch circuits to ensure proper operation of equipment.